In this video, I will guide you through writing your first meaningful program in Python. Additionally, I will introduce you to important language construct in Python. Importantly, no prerequisites are required for this tutorial. To begin working with Python, we'll use the Anaconda distribution for Python. Our coding environment will be Jupyter Notebook, one of the most popular platforms for writing Python code. And we will cover built-in functions in Python, will work with variables, and distinguish between different types of variables. String manipulation will also be part of our discussion. And by the end of this video, you will have an interactive environment to run any Python script and apply what you have learned. So you want to learn Python, but how do you get started coding in Python? First, we need to download and install the Python programming language to our machine. And for that, we will use the Anaconda distribution. So open your browser and search for install Anaconda on Windows. If you're in a different operating system, then search for that instead of Windows. Then click on the pre-download link. Anaconda is a distribution for Python and R programming languages, which is used for big computing, machine learning, and data science. And it has a free version for personal use. And once we install it, it has a package manager called Conda, which allows you to install Python libraries easily because Python offers thousands of libraries. And again, this can be installed in any operating system. Click Download and select the executable file destination folder. Once you have the installer downloaded, open it up and install. Follow the instructions on the dialog. Click Next and accept license agreement by clicking I agree. Your machine might have multiple users, and if you want it to be installed on each user, it requires an administrator privilege. Since I'm the admin of this computer, I will select all users and click Next. Then decide the destination folder of the installation and click Next. For the advanced installation options, we'll let this option selected. This second option is important so that the system will use this Python version by default, which is especially helpful if you have other versions of Python installed on your machine. Then click Install and wait until installation is complete. This could take some time, so be patient. And now we have the Python installed and set up using Anaconda distribution. Look for the Anaconda prompt. First, let's create a directory using the mkdir command and name this directory demo. Then to navigate on that newly created directory, we need to use the cd command and indicate the name of the directory, which is demo. Now let's bring the Python interpreter here by typing Python to see if it is successfully installed. And we can code Python here, but we will use something more intuitive and fun. To exit from the Python interpreter, we just need to type exit and hit enter. Now we need to be on the Conda package manager environment, and that is what the base indicator here means. You don't need to worry about what is environment, we will cover that on a separate topic. Now from here, let's open Jupyter Notebook by typing Jupyter Notebook. Jupyter Notebook is a browser-based interactive shell which helps you write code and view results on the same screen. And it is popular to students starting because of its ease of use. With Jupyter Notebook, you can type your Python code or commands within cells, execute that cells, and see the result of your execution right there within your browser. It will bring up a URL that will open to your default browser. You have to keep this program running because it acts like a Jupyter Notebook server, and you will need this to work on Jupyter Notebook. When you're done, then you can close it. The first page you will see is the Jupyter Notebook homepage. .ipynb is the Jupyter extension, and all the Jupyter Notebook file you create to your current working directory will have this extension. Click New Notebook. Selecting Python 3 will make the notebook run on Python 3 kernel, so your code will be interpreted and run on that kernel. It will open a new tab. Rename the notebook, for example, First Python Notebook. And now we can start to code. But how to code? Well, this box here is a code cell. So you type your code here and hit Shift plus Enter. Shift plus enter or shift enter executes the commands in the code cell and creates a new cell if needed. It will print the result below right after the code cell. Now let's try to write something like the Python dash dash version. Well, this is not a Python command, it's a shell command, and executing this allows us to check what is the latest Python version we are using. Let's start by opening Anaconda prompt, and then let's create a new directory for our Python project. Let's use the mkdir command, and then I will name this directory Python introduction. And then we need to navigate to that directory using the cd command. Make sure that you spell it right. And then once we're on that directory, we can now open the Jupyter Notebook by just typing Jupyter Notebook. And this will open Jupyter Notebook in your default browser like this. And in the case that you want to open it from a different browser, then you can go back to the Anaconda prompt and you can locate this URL generated. You can copy this URL and you can open that to your preferred browser. So now let's go back here in my browser. So we have a new Jupyter Notebook here. First thing I will do is to create a new notebook. Make sure that you select Python 3 so that our code will be executed using the Python 3 kernel. And that will open to a new tab. And before we start, it's a good practice that you rename your notebook first before writing any code. So you can just click here in the Untitled, and then I will just name this numbers in Python because that's the first topic that we will discuss in this introduction series. And hit rename, and that will update your uh, notebook name. If you go back from the home page, you will see that notebook already exists in here. Now let's go back to that notebook. And here you can add more cells by pressing Shift Enter from your keyboard, or you can simply just click this Add button, and that will also insert new code cells in your notebook. And in Python, you can calculate numeric operation. So for example, if we type 8 plus 5 and press Shift Enter, Jupyter Notebook will calculate it and output the result next to the code cell. And here we can see that it outputs 13. So in Python, 8 and 5 are treated as integer values or whole numbers. And aside from integers, Python also supports floating point values or number with decimal points. In this example, we are adding two float values and an integer value. And when executed, if we press Shift Enter, this will result to 23.7. And as you can see here in this example, Python can also calculate a combination of integer and floating point values. And all operations are supported in Python. Another arithmetic operation is subtraction. So here if we subtract 10 from 25 and press Shift Enter, it will result to 15. And we can also perform subtraction with floating point values like 14.6 and 7.2. But be aware that if we execute this, sometimes you will get an arbitrary number of decimal places in the result. And this happen in all languages, not just Python, and is of little concern. Python just try to find a way to represent the result as precisely as possible, which is sometimes difficult given the computers have to represent number internally. Now, if you include different operators in an expression, like in this example, Python will calculate this using the order of operations, also called as precedence. And in this expression, the addition will be calculated first, then the subtraction. The common acronym that developers follow is the PEMDAS, and it helps them remember the order of operation. Now, if we execute this, it will result to 24.5. So PEMDAS stands for parentheses, exponents or powers, multiplication and division from left to right, addition and subtraction from left to right. So expression within a bracket or parenthesis have the highest precedence. Next to that is exponents or powers. And if both of parentheses and exponents are not in an expression, then Python will give higher precedence to multiplication and division, but it will be calculated from left to right. And then addition and subtraction has the least precedence. We can also perform multiplication using the asterisk sign. So if we multiply 5 and 3, then that will result to 15. And we can also mix data type in an expression, like in this example, multiplications of an integer and a floating point value. So if we press Shift Enter, the result will be 48.0. Now take note that when there is a floating point value involved in the operations, the result will always be a floating point value. And here is another expression with multiplication and addition operation, and following the order of precedence, if we press Shift Enter, this will result to 62. So if we try to analyze this expression, what Python will do is first look at the operations with the highest precedence. Since we don't have exponents and brackets or parentheses, then the next is to check if there is a multiplications or divisions involved. Since we have multiplication, Python will give precedence to these operations, and again it will be calculated from left to right. So these operations will be calculated first, and this will result to 20. And then after that, we have another multiplication operation. So 20 times 3 will result to 60. And then the last operation is the addition operation. So if we add 60 and 2, that will result to 62. But if you want a certain operations to get calculated first, you can use the parenthesis. And doing it will let Python give a higher precedence to that operation. So notice here that if we execute this line, the result when we use the parenthesis is different now. Previously, the result is 62. Now, because of the different order of operations, the result now becomes 100. Another operation is the power of operations or exponentiation, which uses the double asterisk sign. So if we execute this, it will result to 24. And again, if you use a floating point value, result will be always a floating point value. So if we use power of operations with 2.4 and 2, that will result to 5.76. And another operations that we can do is the division operation, which uses the backward slash sign. And this operation always results to a floating point value. So if you divide 20 and 10, that will result to 2.0. Even if 20 and 10 values are both integer value, the division operations always results to a floating point value. But if you are only interested in the quotient without the remainder, then you can use the integer division operation, which uses the double backward slash sign. So if we try to divide 20 and 8, then that will result to 2. And always remember that when a floating value or floating point value is involved within the operations, the result will always be a floating point value. Now, in the case that you are only interested with the remainder after division, then you can use the modulo operation, which uses the percentage sign. So if we execute this code, it will result 2 because 12 divided by 5 is 2 with remainder of 2. And that is what this operation return, the remainder part of the calculation, which is 2. And this is a very helpful command, not just in Python language, but also in other languages. So here is another complex operations that Python computed using the order of precedence. So if we execute this, it will result to negative 47.0. So if we will try to analyze this expression using the order of precedence, what Python will do first is to execute this expression within the bracket, and then after that, we have both multiplication and division available here. But again, Python will read it from left to right. So multiplications will be executed first, and then after that is division. And then the last operation is the subtraction. And that will result to 47.0. And you need to be aware that in Python, you can also use the multiplication operation with a string and an integer value. In this example, if we execute this code, we can see that hello is repeated 5 times. You can also do 5 times hello instead, and if you execute this code, that will result to almost the same value. I forgot to add space in my text. And multiplication is the only operation that works with string and integer value. So if you try to use addition operation, in this case, for example, then if you execute that kind of syntax, then you will get a type error from Python because here Python see that you are using the addition operation, and when there's a string data type involved in that operation, remember that Python will use concatenation operation. But since here the other value is an integer value, then Python doesn't know how to add these two different data type value, and that result to a type error. Here I created a new notebook and named it built-in function. So now let's see how we can use some of the built-in functions in Python. Well, functions are a reusable bit of code that performs calculations or action, then give a result. So where this function comes from? Well, they are part of the Python standard library, which is a collection of modules and packages that provide a wide range of functionality to support common programming tasks. And built-in functions, as the name suggests, are the functions that are available by default in any Python environment without the need for additional imports. And we can also create our own custom functions, but that's another topic that we will cover separately. So here, if we try to write a string value and execute it, Python will simply echo it. And here we can see that the output now is within a single quote. So one common function in Python is the print function. And a function always have a name, in this case is print, and also a bracket or parenthesis. And inside those parentheses are the input parameters that the functions needs. So this command is telling Python that we are invoking the print function and we are specifying a value good job learning Python as the input parameter. So if I execute this code cell, then it will print good job learning Python. And notice the difference when we use the print functions. Now our output text is not contained or within a quote sign. And the print function support both single and double quotes. So this time if I use a single quote and execute this code cell, then this results to the same text value as you can see here. But if you forgot to include a quote, then Python will not understand the command. So if I execute this code, then Python will raise a syntax error because this command that we are trying to execute does not follow a valid syntax. And in Python, syntax is a command structure that Python can understand. Another built-in function in Python is the len function, which returns the length or the number of items of an object like a list or a string. In this example, len counts the number of character in the string value that we specify, and if we execute this code cell, this will return 24. And we can also use the print function to output the result of a calculation or expression. So when Python see a command like this, it will calculate the expression first and then pass the result to the print function. So if we execute this code cell, then the print function will output the result of the calculation to the screen. And this results to 25. So I'll let you try to use the print function for other complex calculation so you can try it within your Jupyter Notebook. And another built-in function is the abs functions that returns the absolute value of a number. And we can use it to an integer, a floating point number, or even a complex number. So in this example, if we use the abs functions with the value 21, this will returns 21 because 21 is the absolute value of 21. Now if we try to check the absolute value of a negative 21, then again that will result to 21 because that's the absolute value of negative 21. Then we also have the type function, which is commonly used to determine the data type of a variable or an expression. In this example, if we execute this code, then it will return int because the value that we specify in this function is a whole number. But if we try to specify a floating point number and execute this function, then it will return float because Python can identify that the number contains a decimal places and it will be considered as a float data type. And for a string value or anything within a quote, Python will always return str or a string data type. Another function is the round function, which is used to round a number to the nearest integer. So if we try to use these functions with the number 21.5, then it will return 22. Similarly, we can also use this for negative values, like for example, negative 21.5. Now this time it will return negative 22. And then the max functions that returns the maximum value from a sequence or list of values. And for max functions, we can specify any number of input arguments. So in this example, if I execute this code, then it will return 5 because 5 is the highest value or number within this list of number. And if we have the max function, then we also have the min function that returns the minimum value for a sequence or list of value. So in this case, if we execute this command, then it will return 1 because that's the lowest or the minimum value that we have on this list of numbers. And these functions are essential part of Python and provide fundamental functionality that is commonly used in many programs. And they are always available without the need for additional installations or imports, which make them easily accessible for all Python programmers. Here I created a new notebook and name it variable. And having understood the mathematical and built-in function concept, let's now move to a more advanced concept, which is using variables in Python. So if we type 500 and execute it, we know that Python will just echo this value. Now if we subtract 250 from 500, Python will identify that this is an expression. So it will be calculated and then return the result, which is 250. But let's say that you want to use this computed result 250 in another place. So you have to recompute it because it is not stored anywhere. And that's where the importance of variable come in. So variables are containers that hold values, and these values can be updated. And values you can store to a variable could be a number, a string, or a computed result. So this command here is called initializing variable or initialization. So when Python see a command like this, then Python assigns the value 4500 to a variable named payment. So our variable here is the payment, which now contains the value 4500. So now if we try to execute the variable payment, Python will output the value it contains, which is 4500. And here we assign another values to variables electric bill and water bill. So now if we execute this variable, Python will output the value of this variable. So electric bill is 1200 and water bill is 900. And this time we can compute the sum of the electric bill and water bill and then assign the result to another variable, which is the total bill variable name. And this is a complete valid command in Python. So now if we execute this code and if we check the total bill variable, it will return the sum of the electric bill and the water bill variable values. And here we can compute the remaining balance by subtracting the total bill from the payment and then assign the result to another variable. This time is the balance variable name. So if we execute this calculation and if we check the value of the balance variable, it will return 2400. And these examples show how we can easily access the values when they are stored in a variable. Now, using the print function, we can print the remaining balance. And notice here that we specify two input argument to the print function. And if we execute this, then the print function output these two values in a concatenated manner. So another example to calculate a total payment based on hourly rate and number of working hours. So here we assign a value to each variables and then compute the result and then assign to a variable total payment. So if we execute this code and if we check the value of total payment, we can just use the variable name total payment and that results to 2000. So the characters allowed in variable name is capital A to Z, and then lowercase a to Z, and number 0 to 9, and also an underscore character. So no other characters is allowed, and then variable name should always starts with a letter or underscore, but not a digit. And we can also pass a variable operation to a print function like what we do here in this example. First, we initialize variable x and y by assigning a value to both of them. And then we calculate the sum of x plus y in or within a print function. So in this command, Python will first compute the x plus y and then pass the result to the print function. So if we execute this, this will output 15. But if we want to store the result permanently, then we can store the result of the x plus y calculation to a variable. For example, is the total variable name. So we can access the result every time we need that value by just using the total variable. Now in Python, if we use the addition operation with two string values, then Python will interpret it as a concatenate operation and it will output the combination of the two values. So if we execute this code, then what you can see here is that it combined both those value into just one text. And remember that addition only works on values with the same data type. So in this example, if we try to add two values with different data type, and if we execute this, then we'll get a type error. And why it's a type error? Well, we can verify that by using the type function. Remember that type function can be used to return the or to determine the data type of the value we specify. So if we check the type of variable x and the type of variable y, then this results to an integer and a string, which are two different data types, and Python doesn't know how to add values with two different data types. We've already worked with int, float, and string. Another data type that we haven't discussed yet is Boolean, which refers to the value true and false. In Python, true and false should start with an uppercase. And you will notice that when we assign the value true and false, Python highlighted these values in the green colors, which means that these are keywords that Python understands. So now let me execute this code. And another operation that Python support is the logical operation, which involve the use of logical operator to perform Boolean logic. So logical AND is one of the logical operator that returns true if both operands are true, otherwise it returns false. So if we execute this code, it returns false because X is true and Y is false. Another logical operator is the logical OR, which returns true if at least one of the operand is true, then return false if both are false. So if we execute this code, it will return true because we have one operand with a value of true. And lastly is the logical NOT operator that returns the opposite Boolean value of the operand. So if the operand is true, not return false and vice versa. So if we execute this code, we know that X is true, so that it will return the opposite of that operand, which is false. In this example, we assign a value Python to a variable code. So if we execute this, when we check the value of code, it now output Python. Then we can use the print function and pass a concatenate operation which combines the string value I love and the value of the code variable. So if we execute this function, it outputs I love Python. And remember that variable can be updated by assigning a new value to it. So in this example, we assign a new value, power platform, to the code variable. So now if we check the value of the code variable, it now shows the new value power platform. So here is another example where I assign the value I love to a variable A, and then we use a concatenate, or we concatenate A to the code variable and then assign the result to the variable message. And then we use the print functions to output the value of the message variable. So if we execute this code, it outputs I love Power Platform. And we can also pass a variable to other built-in function like the len function. So when executed, it will return the number of characters in our variable value, which is 14. Now we can also pass the message variable to the len function, and this will return 21. There are many different ways to assign values to variable. So this example is completely a valid syntax in Python. So in Python, assignment operations are always evaluated from right to left. So in this expression, the Python string value will first get assigned to variable C, then the value of C will get assigned to variable B, and lastly, the value of B will be assigned to variable A. So now if we execute this code, and if we print these three variable values, we can see that they all just have the same value, which is Python. And again, we can add two string values and Python will interpret it as a concatenate operation. So if we add the value of A and B and assign that to variable D, and if we check the value of the variable D, we can see that it contains Python. And another operator that we haven't discussed yet is the comparison operator, which are used to compare two values and determine the relationship between them. So this operator returns a Boolean result true or false based on the specified condition. So in this example, we compare the value of variable A and B using the double equal sign. So we can read this expression as A is equals to B, and when executed, it will return true because A is indeed equals to B because they contain the same value, which is Python. And these are the other comparison operators that are available in Python. So the equal operator, less than, greater than, less than or equal, and greater than or equal. Now in this example, complex expression, remember that Python will always evaluate it from right to left. So here Python will first check if B is equals to C, which will result true, and then the comparison result true is assigned to the variable A. So now if we execute this code and print the value of A, we get the result true. Now in this example, we are assigning different type of value in different variables. And this is also a valid syntax in Python. So the string Python will be assigned to X, the floating point number 3.7 to Y, and the integer value 21 to Z. So if we execute this code, and if we use the print function to check the value of these variables, we can see that X is Python, Y is 3.7, and Z is 21. And here we have two names variable, name1 and name2, and they contain different values. And we can see that using the print function. So if we execute this code, it prints John and Kevin. And now if we assign the name1 value to a new variable name3, we have now two different containers having the same value John, because name1 variable value is John, and since we assign name1 to variable name3, then name3 variable now contains also the value John. And we can check that using the print function. So if we execute this code, now we can see that the value of name1 and name3 variable are both John. Now if we assign name2 variable value to name1, then name1 value will be updated based on the name2 value. We know that name2 is Kevin. So now if we execute this code, the name1 value will be updated to Kevin. So if we print the names again, we can see that name 1 is now updated to Kevin after assigning the variable name 2. But notice here that the name 3 value did not change because even if the value of name 3 came from name 1, they are no longer connected to each other after the assignment operations, and it will not have any effect even if we change the value of name 1. Now let's see further how variable act as container and how we can change the value lives in this container. So here we have three number variables num1, num2, and num3, and we initialize these variables by assigning initial values. Then we also have two string variable that contains some text. And then here we calculate the sum of the three numbers and assign the result to a variable total num. And this is another way of initializing variable by assigning to it the result of a calculation. So now if we check the value of the total num variable, it will return 233.5, which is the sum of our three number variables. Another idea of a variable is that the value it holds can change. In this example, we use the num1 variable again and assign a result of calculation. So Python read it by taking the existing value of num1 first and then add 1, then assign or store the result back to num1. So now if we check the value of num1, it is now 22 from its original value, which is 21. And similarly, if we take the existing value of num2, add 10 and assign the result back to num2, and if we check the value of num2, now it becomes 22.5 from its original value, which is 12.5. And of course, we can use all type of operators in a calculation and assign the result to a variable. So here in this example, we are using the subtraction operation by subtracting the value 50 from the existing value of num3, and then we assign the result back to the variable num3. So with this calculation, if we check the value of num3 variable, now it becomes 150. And here is another example of multiplication operation and also division operation. And notice how Python processes this. It always take the existing value of the variable num3 and then perform the calculation and assign the result back to variable num3. So now the value of our num3 from 200, now it becomes 6.0. And you will also encounter interesting syntax like this. So in this expression, Python will first take the existing value of num1 and then add 1. And then the result will be then added again to the existing value of num1. And what do you think will be the result if we print num1? So if we are Python and we are going to process it, the existing value of num1 is 22. So if we add 1 to it, it will become 23. Then the plus equal operation here means that adding the existing value of num1 to the result of our initial calculation, which is 23. So 23 plus 22 is equals to 45. So if we execute this, we get 25. So did you get the, or did you guess the correct answer to that? Okay, so here is another example. What do you think will be the output of this calculation? So again, Python will first take the existing value of num2, which is 22.5 or 22.5. That is the last value of our num2 variable. And then we add 10. So that becomes 32.5, and then we assign it back to the variable num2. So now if we print num2, it should be 32.5. And remember that when addition operation is used in a string values, the operation will become a concatenate operation. So remember our S1 and S2 value is deep and work. So if we add S1 and S2 and assign the result to a new str variable, and if we print the new str variable, we can see that the concatenated value of S1 and S2 is deep work. But now if we change the value of variable S1 to shallow and we print its content, we can see that the updated value of S1 is now shallow. But if we again print the new str variable, we can see that changing the value of s1 did not affect the value of the new str variable. It's because once you created a container or variable, then it will continuously hold that value unless you explicitly change the value by assigning a new one. We already talked about different data type in Python. Now let's quickly look at other data types available in Python. So the data type we have covered so far are built-in data type or basic data type. And in Python, you can create your own data type using classes, but that is an advanced topic and we'll cover that separately. So remember in Python that you can use the function type to return the data type of a value. So in this example, 19 returns int or an integer. And then if Python see a decimal place on a number value, it will identify it as a float data type. And in this example, you will notice that we are passing four input arguments to the print function, and we also use the type functions to a variable a. So when Python see a syntax like this, it will first take the result of the type function and then take the existing value of a and concatenate the result, then pass to the print function. So if we execute this command, then it will display the concatenated value of all the arguments that we specify within the print function. Another data type that Python support is complex data type. So here we are assigning a complex number to variable b. So if we check the type of that variable, then Python knows that it's a complex number and it can identify it as a complex data type. That's why it returns complex. And we can also perform operations on complex number like in this example, and this result to this output. And another common data type in Python is the Boolean of type bool. So if we check the type of the variable, that returns bool. And of course, anything enclosed by a quote is considered a string data type. So if we execute this command, then it returns str or string. And Python also supports binary number, but you need to prefix it with a 0b so that Python will know that it's a binary number. Now, if you check what is the data type of this kind of value, I'm not sure if you expect a binary data type, but if we use the print function, then it will return int data type because binary number are also part of the integer data type number. Again, anything enclosed by a quote is considered by Python as string. So either it uses a single or a double quote. So in this example, we print two values using single and double quotes, and Python print it the same way. Now in this print statement, we use three different type of quotes, the double, single, and triple quotes. And if we execute this code, Python considered them all just as a string and concatenated them because of the plus operator. And here we introduce a special function in Python, the input function. And this function allows to accept a value from a user and then assign that value to the variable name. Then we use a print function to concatenate the value of name variable to our text hello. So once we execute this code, you will see this box, which is the input box that will wait for our input before it execute the next code, which is the print command. So once we provide the value and hit enter, then Python will execute the print function, which print hello and then the name that we provided. Now in the case that your string value contains a single quote, and that string should be enclosed by a double quote, because if not, then Python will raise a syntax error. So in that case that you have a single quote in your text or in your string, then you have to enclose that text within a double quote, and this will not be raising a syntax error. But in the case that your string value contains a double quote this time, then you should enclose the complete string with a single quote like in this example. Now, other way to avoid getting a syntax error from Python is by using an escape character prior the quote. So if your string contain a quote like in this example, I place the escape character before the quote, which make the syntax now valid. So if we execute this, we will not get a syntax error. And we can see that the single quote character is also printed in our screen. And you can also use this escape character in any character that causing syntax errors to your code. Though it's not recommended that you do it this way. I think it will just make the code looks complicated using escape character, especially if there are lots of special characters involved within the text. Another special character you can use within a string is the new line character represented by the \n. And Python interpret it by adding a new line to the string value. So if we print this, then we can see that the Pythonese tag goes to the next line when we print this value or text that we specify. But the best way to print a multi-line text is by using the triple quotes or triple double quote. And this is mostly used in documentation that you will find in most of the codes that you will encounter probably in the future. And I highly recommend getting familiar with it. So now if we try to print this command, we can see that it returns the text in one line and then interpreted those new line by a \n. And again, that approach only works with triple quotes or triple double quotes, so you cannot pass or use this format with single or double quotes like in this example. You will get a syntax error from Python. Another special characters in Python is the \t, which is interpreted by Python as a tab. So executing this code, you will see in the output that a tab is concatenated to our string or to our text. Well, you might ask, what if your text contains a backslash or an escape character? How will you escape it so it will not be a syntax error? Well, the simple answer to that is just use a double backslash or escape character, and Python will consider the next character to the backslash as a regular character or just the normal character. So in this example, if we execute that print command, then we can see here that we were able to print the backslash character because we use an escape character prior to those characters. And what we usually do to format a string so far is through a manual concatenation by using the plus operator. And this way sometimes can make your code hard to read. So now if we execute this code, this was able to concatenate our string value. It print Jim Quick wrote limitless. And one way to format string in Python is using the f-string or f-prefix. To use it, you just need to put an f before the quote, then inside the quote, you can include variable by using the curly braces. So Python will acknowledge that this format is a variable and take its existing value. So that's why when this is executed, it outputs the value of that variable limitless. And with fstring, anything within the curly braces is treated as a variable or expression. But if you don't use the f prefix, the book enclosed by curly braces will be treated just a regular text. So this f prefix or f string works for both double and single quotes. Another string formatting is using the dot format function. So, and to use this, you will add a curly braces placeholder within the text and then use the dot format function and then specify the variable or value that you want to pass on that placeholder. So in this example, Python will first take the value of variable book and then pass to the placeholder we have on the text. So when print is executed, then Python will print the value passed to the placeholder. And take note here that the number of placeholder should match the number of variable or values that you pass. And that is all for this video, guys. If you like this video, please hit that like button and you can subscribe so you'll get updated for our next Python video. So for the next video, we'll work on complex data types in Python. We'll work with lists and tuples. So I'll see you there.